the 61-inch.
The mother of all telescopes. Oh, on the way down.
Yeah.
So this side.
Welcome to Kitt National Observatory in Tucson, Arizona.
Felix, are you happy?
Yeah, go inside. There's 4-meter telescope.
It's okay.
I'm wondering how to open the door.
I want to go out there. Whoa. It's really small. Personal, private.
Not to the 12 meter.
Out of the side that's facing us.
Yeah.
That's basically the level of the 4-meter primary mirror. And up at the top, you see a black hose. Those are dust covers, and that's the secondary mirror. So light comes down from the top, hits the primary horseshoe here, which you can't see. It is possible to get in and out of that focus area with a walkway that's behind the telescope. And that's what that net is for. Sometimes people or equipment could take a little tumble there. I don't know of any people who have. The white part moves towards us and away from us inside of that blue horseshoe. Do you see the blue horseshoe?
Yes.
Yeah.
So the white part moves north-south, what astronomers call declination, and the horseshoe slides the perpendicular direction east-west, and it literally does slide on a thin little film of oil. It looks a little shiny on the outside gray area. That's the part that slides east-west in what astronomers call right ascension. The whole dome above us moves.
Thank you. Foundation.
John? The second thing I want you to experience is the size of the building. There are two ways to do that. One is to look up as tall as you can. You see that floor up there? Yeah. That's where we were standing. And every several years, during the months of July or August, when it's normally raining here, the idea is you take the 4-meter telescope mirror out of the telescope and you lower it down here onto a platform that slides on these rails. I want to bring your attention again to the rails that you could trip over. Do you see them?
No.
Okay. And the mirror sits here. And then you clean it. In fact, you not only clean it, you etch this every few years. They do that here. And then they slide it into this tank. The top of the tank lifts up on those stilts. You put the mirror basically inside, put the lid down, pump a vacuum in there, and then we're going to melt a very thin layer of aluminum on it. And inside that tank are these aluminum electrodes. Just like a toaster coil. Have you ever looked inside a convection oven or a toaster coil? You see it glowing. Well, when these glow at a little higher temperature, the aluminum evaporates, and it makes a gas inside that coats the coating. Tonight I will make this statement, but it's true here too. The mirrors you'll see tonight are 20 tons of glass. Take 2 years, 1 ounce of aluminum atoms that have been evaporated onto the surface. 1 Coke can of metal is essentially worth $20 million. Wow. So that all the different colors of light reflect off the front surface. They never go through the glass. And so this is a piece of technology too. And learning how to evaporate a very uniform coating
That's the amount of aluminum.
If the mirror were as big as the United States, you couldn't have any ups and downs more than like half an inch. So this is the illuminizing chamber. They not only illuminize the 4-meter mirror, they illuminize other mirrors here from other telescopes on the mountain. That's a big summertime activity that occurs.
It does a pretty good job of.
Inside of here, that's not the top. That's just one section. Let's hear how long the echo.
Yeah, make it.
Raise your hand and you can stop. This is the structure that goes onto the telescope that keeps it isolated from motion. What do we call it? Pier. Thank you.
Yes.
So this is the rest of observatories in Kitt Peak.
Telescope.
You see that weird structure over there? That's a solar telescope. And see that radio dish over there?
Yeah. That's the radio telescope, right?
That's a radio telescope.
How's your trip so far?
Very, very interesting.
Nice.
Very nice.
Have a really big.
While you're exploring this room and the hallway, I will go set up the telescope, and hopefully we can see the sun. Hopefully I don't screw that up.
It's the
Now,
brightness over
on the way down, you saw the telescope, but it didn't look red, and didn't have those stripes going by.
This is our This is the core. The temperature is about 37 million Fahrenheit. It's about 15 million Celsius. So inside the core is hot enough for nuclear fusion. So nuclear fusion is basically an atom and another atom fused together to form a heavier atom.
protection.
Felix got that. Oh, cameraman.
The solar telescope. Wow, it's amazing. So so the solar telescope works like this. There will be a mirror at the top of the building, which like it will adjust itself to like align with the sun, so it can reflect with the other mirrors inside. You see a hole up there? Look at that. There will be a mirror up there that reflects light from the sun down to that platform there. So currently there's nothing on the sun because of atmospheric refraction by the clouds. and by some ice crystals in the upper atmosphere. So we can see the sun in high resolution.
That's the mirror.
Yeah, they call it a heliostat mirror. So the mirror lights itself so that the sun's light reflects onto the other mirrors that leads down there. So these actually
Like without sunglasses on.
We're looking at it.
Yeah, but it's not a small one. Yeah, it's small.
This is a much smaller mirror.
Yeah. The other one.
That's
This
reflecting
is
the light
more,
down.
but it's not.
Boiling and churning.
And your nice one's got one.
The only one that I could find is a tiny one. Right there.